Okay. Looking at a radical function, needing to find its inverse, that's all right. We're going to approach it the same exact way. Step 1 says we replace f of x with y. So we have y is equal to the 7th root of x minus 3. Step 2 says we need to switch x and y. So we're going to have x is equal to the 7th root of y minus 3. Third step is solve for y. So I'm going to rewrite this with y on the left-hand side, as we are trying to solve for y. Here I have a 7th root. So to get rid of a 7th root, we're going to take both sides of our equation to the 7th power. Just like if we had a square root, we would square both sides to undo it. Here, we need to get rid of the 7th root. So we're going to get rid of the 7th root by taking it to the 7th power. Y minus 3 becomes x to the 7. Add 3 to both sides. Y is equal to x to the 7 plus 3. And our last step of finding an inverse, replace with inverse notation. F inverse of x is equal to x to the 7th plus 3. We're asked to find the domain and range of both. And again, I like to use this chart because it keeps it nice and organized for me. My columns will be f of x and f inverse of x. Okay, our original function is a radical function, but his index of 7 is odd. And because he has an odd index, the domain is going to be negative infinity to positive infinity. And if we found the domain of the original, that means that we found the range of the inverse. And if we look at our inverse function, we have x to the 7th plus 3. This is one of our friends. This is a polynomial, which means its domain is negative infinity to positive infinity. And if we found the domain of the inverse, that means that we found the range of the original. Okay, we're going from our friends to someone who's not really our friend, just because he's a fraction on steroids. Our frenemies, I guess you could call them, of a rational function. Okay? But finding the inverse is still the same. Step 1, replace f of x with y. So y is equal to 4 over x plus 9. Step 2, switch x and y. X is equal to 4 all over y plus 9. Step 3, we're going to solve for y. We have y plus 9 in a denominator. So what we're going to do is take y plus 9, multiply it on each side of our equation. Because on the right-hand side, the y plus 9's cancel out. On the left-hand side, we have x times y plus 9 equal to 4. And I know some of you may divide by x and move on from there, but I really want you to pay attention to this next step because it will help you when our problems are a bit more involved with our rationals. So we can distribute the x through the parentheses. If we do that, we have xy plus 9x equal to 4. And remember, we are trying to solve this equation for y, which means I need to get anything without a y to the other side of the equation. So I'm going to subtract 9x from both sides. I have xy is equal to 4 minus 9x. And then to get y by itself, we need to divide both sides of our equation by x. And in doing that, left-hand side, the x's cancel. So I have y is equal to 4 minus 9x all over x. And remember, the x's here don't cancel. Up top, it's attached to the 9 and the 4. Down below, it's single. So no trying to cancel it out. And then remember, our fourth step is our function notation. F inverse of x equal to 4 minus 9x all over x. But of course, we still need to do domain and range. Again, I'm going to do my chart, domain, range, my original function. Need a little bit more room this time. Because my domains are going to be a little bit longer because they are rationals. Okay, so of the original function, let's find the restricted values of f of x. We take our denominator, set it equal to 0, find out x cannot be negative 9. So if we are doing our little number line to help us with interval notation, we're saying that x cannot be negative 9. So our domain is going to be negative infinity to negative 9 with a parenthesis. We need to jump over negative 9, which means we need the jump rope, the union, and then negative 9 to infinity. If we found the domain of the original, we found the range of the inverse. So we're going to copy that back down. Negative infinity to negative 9, union negative 9 to infinity. Let's look at our restricted values of our inverse. Take your denominator, set it equal to 0. We find out that x cannot be 0. So negative infinity to 0 on up to infinity, remembering that we cannot be 0. Which means that we are going to have negative infinity to 0, union 0 to infinity for the domain of our inverse. If we found the domain of the inverse, that means that we found the range of the original. So go ahead and copy it back down. Negative infinity is 0, union 0 to infinity, and it must be in that order. Let's try one more. Inverse of another rational. But this time we have x's in top and bottom, so in the numerator and denominator. Step 1, we're going to replace g of x with y. So y is equal to x plus 2 over x minus 6. Step 2 says that we flip the x and y. So x is equal to y plus 2 all over y minus 6. Step 3 says that we need to solve for y. And much like in the last one, we're going to multiply both sides of our equation by the denominator on that right-hand side. So I'm putting parentheses around my big fraction because we are going to multiply by the y minus 6. The right-hand side, they cancel out, which means that we have x times y minus 6 equal to y plus 2. Here, if you were to divide by x, you would just get yourself into a bigger mess, which is why on the last example, I said, let's just go ahead and distribute. That way we're not trying to scramble and figure out how is this equation different than our last one. Just go ahead and distribute your x. So we get xy minus 6x is equal to y plus 2. Remember, we are trying to solve for y, but right now y shows up on both sides of our equation, so we need to do a little bit of work. I'm going to add 6x to both sides because I know I need to get all my y's on one side, all of my x's and numbers on the other. So I have xy is equal to y plus 6x plus 2. And I need to subtract y from both sides, but I cannot combine the xy with the negative y. What I can do is notice that we have y in both terms on the left-hand side, which means I can factor out a y. If I factor out a y from the first term, I have x minus 1 equal to 6x plus 2. To get y by itself, I need to divide both sides of my equation by x minus 1. And then in my last step, because I had a g of x, this time when I do my inverse, I need to do g inverse of x because I don't want to call him by the wrong name. Okay, so next step, last step, we need to find the domain and range of both of our functions. So I'm going to come up here, do my chart again. And because we're dealing with rationals, give yourself enough room. Remember that we're using g of x and g inverse of x. So if we start with the domain of g of x, take your denominator, set it equal to 0. We find out that x cannot be 6. If you want to do the number line, you can. Remember, we're not going to use 6. So we're going to have negative infinity to 6, union 6 to infinity. And if we found the domain of the original, we found the range of the inverse. And then let's go ahead and find the domain of our inverse. Remember, we are going to take our denominator, set it equal to 0. So x minus 1 equal to 0 tells us that x cannot be 1. If you want to do the number line, go ahead, especially if it helps you. And we cannot be 1, which means we are going to have negative infinity to 1. We need to jump over the 1, so jump rope union 1 to infinity. And if we found the domain of the inverse, we found the range of the original. Exact same.